Hi, Dr. Dheeraj.
Hi, Lord. Yeah, so
Yeah.
we can
Can we continue,
start.
sir?
Yeah, please.
Yeah, all right. Saurav, you there?
Yes, sir.
Yeah, please continue. Thank you.
Okay.
Sir, I have a doubt. Can I ask now?
Yes, sure.
So I'm Praneeth. So while importing the file to design metal sheet, I'm getting an error that you don't have the privilege to import.
Yeah. Just select a leader role. Okay, I will show you. This is your user interface, right? Just go to here, the whatever collaboration space you have. Okay. So here you get access role and organization. Okay. Check that what role you assign. Okay. So I will click here the edit icon. Okay. And here you will see the role as leader. Okay. So make sure you have a you are working as a leader role on the platform. Okay.
So I think I'm unable to do it actually because I'm a author and I don't have privilege to change the permissions, I guess.
Okay. So you are working on the same collaboration space, right?
Yeah, yes, sir.
Okay. So change your collaboration space. If you have created any your own collaboration space, did you create any collaboration space?
Yeah, I did on my own collaboration space.
Okay.
Okay, sir,
So
I'll keep that.
select that collaboration space. In my case is IIT Ropar. Okay. So I will click this and check again with the role. So here you can see the author role is removed. I have just leader and owner role.
Yes, sir, now it's
Okay.
happening. Thank you, sir.
Yeah. Good. Okay. So what last assembly menu, no? We fix the middle part in the X design and we're trying to move it in 3D X shape. So there is a little bit conflict that in mate, no, in X design mate, you will not see mate that fix. Okay. But in case of 3D experience, you can see the mate fix. You can see here that it's fixed. Okay. So in engineering collection, you can see that is the one part is fixed. Okay. So again I will simply do one simple thing, that is I will remove that mat. Okay. To remove that mat, just click on the part, select the shortcut features, click on drop down arrow, and here you can see remove mat, float mat. Okay, remove mat or the float mat. This is fixed and you have to shift it to float. Okay, so you can see now it's float. Okay, and to check it is floating or not, you can move this part. Okay, so now I'm going to save it again. So when I will save, it will save in the collaboration space. Okay, so I will save it. So now your old AMS coupling is saved without any fixed mate. Now back to our assembly. Open our first. Okay, anyone have any problem in XDesign app? How I will remove the mate which I created, fixed mate. First you have to create a fixed mate, because if no part is fixed, no, the mate is not going to be applied. You need to be one part fixed. According to that part, all the mates are applied, or component move according to that fixed part. Okay, so make sure that the one part is fixed. So at the end of the assembly, after completing assembly, just remove that mate, so it will not affect. Okay, so yeah, so everyone is with me, or have any facing any problem or issue, or facing any challenges? Anyone doubts? Okay, so here I remove the at fix mate and save the assembly again. Okay, so now in 3D experience platform, I will go open in my content. I will go to search bar in my content. Just I'm clicking single time. Okay, you will see all the assembly or all whatever files we have, or I have. So just in this old times coupling, I will click on drop down and just open. You can view this, explore this, but we have to edit the part file. Okay, So I will open. So here you can see last time there is a one red arrow showing here, removed now. So that is show that this is now flexible or float can move. So just to move it, no, we will check, just select any component. Okay, just wait a minute. We are in a mechanical system design app. Okay, so first of all we need to go back to the assembly design, or we can create assembly from this command also. Okay, so I will going to create assembly, but before that, first of we will switch to assembly design. It's assembly design app, and just click. So you can see I'm in now in assembly design app. Anyone have any doubt till the point? Are you on with me? Are you with me, or have any doubt? So I will follow the same procedure to add the mounting plate, the mounting base, assembly. So go to product modification, select insert existing part. Okay, I will select existing part, or that is existing part. Select the old hands coupling. Okay, wait a minute, existing part. Okay, now search in my content what the mounting base. Okay, the mounting base. Okay, so here I'm selecting the mounting base. You will see it's showing the one arrow. Okay, it will show a one arrow that you selected one part. So select this, click on select this on, if you base and show the details, but make sure you click on the right button. Okay, right arrow, so it will help you to select and click on accept all. Okay, anyone have any problem, any doubts? Anyone have any doubts or facing challenges at any point of time, any point? Hello? No. Okay, so first of all what we do, we will fix this mounting base. Okay, so let's fix this. Just click on the mounting base and you will get shortcut toolbar. Just select fix. So this is your reference for all the mates. Okay, and update all the mate. So you will see and understand if there is, I will show you something. Wait. So now create a connection. To create a connection or mates, go to assembly, engineering connection. Okay, just click one times in engineering. You just have to select the page. You can see select any points. Okay, so I'm going to select the axis, select this axis and just zoom in and zoom out. Okay, so in how regarding the mouse control, do everyone understand how to control zoom out and drag or pan? Okay, just doing a zoom in, just middle mouse and the right click. So I'm just select the middle mouse, right click, zoom in, zoom out. I will select the axis, this axis and the axis of this. Okay, so this axis. You can see the two axes are selected. Which axis and just axis, you will understand that you selected the axis of this part, and for this which axis is this? This is the axis of mounting plate. Okay, so first is created. Now we have to just create a offset. Okay, so to create a offset, just select the face, first face of the right and left disc and second face, okay, of the mounting plate. So you can see that now you can see it's flipped totally. To change it direction, to move it in opposite direction, it is in opposite. So select this preferences, okay, and just right click and save, select as same. Okay, now to take it something back offset to create offset, just go to the type of mat. Okay, click right click, replace by an offset mat. Okay, so here you will get a value by which but by how much value you want to do offset. Just do it by -10. Why -10? Because in +10 it will go offset in that direction in up forward, but we want it in backward, so we'll do it -10. Okay, just click OK. Just see yes. So now you will see that is the two things, the pragmatic and revolute having showing some circle on the mat, because that show that the mat is not updated. To update all the mates, just click update, so it will be disappear. Okay, so same for the this also, create connection. Just okay, anyone have any doubts regarding this? Because this is very important step in for creating a mechanism. Okay, if you not understand how to create a mate or how to select, it will be difficult for you to create a mechanism. Okay, so select the engineering connection, select the axis, again select the axis of mounting plate, and it align properly. Okay, yes, now you can see, just I will update all the my mates. Okay, now to understand that's the all mates are properly applied. Okay, select any one parts, that is any right plane or middle disk, any disk. Okay, just select. So you will get a robot here, move select command, or we can call it robot. Just select this, so you will get a different ways to move this part. Okay, so if you drag this, it will not going to move because it's constrained in such a way. Okay, so just it will get rotate, and if you see it's rotated with every means, to visualize it clearly, let's we apply the material in assembly also. Okay, so it will not take much more time. Okay, anyone get problem in robot, or we can say the manipulation, because it's important to manipulate time. uh, you're not getting the proper surface to apply the mat. Okay, for that purpose you need to manipulate the part, view the surface and apply the mat. In, we are going to apply material in tool. Just wait a minute, we will display that only. So in tool, no, having a lot of commands. Okay, so we're going to show see the material browse. Okay, so material, just drop down. Now I can apply material to all three parts at a time, just by click this material, drag it, hold it on any parts that you want apply material. So I'm holding it on middle disk. Okay, and release your control. Okay, so this is just a drag and drop feature. Just drag, hold the material first, drag it to your part and drop it. So here you will get option about replace the mode and applied material to the middle disk. Okay, so you can apply material on old hands coupling, on a shape, on or apply down on extrude. Okay, so just select apply on middle disk and click close command, so it will get applied first. Okay, next we are going plain carbon steel. Just hold it, drop on right disk, apply, and same for the this one also, hold it, apply, and yeah. So now you see there is it's not showing the material. So for that, no, just check out, you are in a material tab, showing grading, shading. Okay, and yes, update your assembly. So what I'm getting problem in. So we already applied material in the XDesign app, no, so it will not able to show the applied on the assembly tab also. So instead of applying material, we will move forward to create the mechanism. Okay, so I think it's clear for everyone. Anyone have any doubts regarding the mechanism creation? You can apply at any point of time. Okay, there is no issue with it, but we already applied this material on XDesign app, so that's it creating some issue. Okay. So shall I move forward to create a mechanism? So create a mechanism, there is a very important feature. Let's take time to load, sir. Okay. Yeah. Just listen that to create a mechanism, you need a free end, okay, which help you to move the part related to others, okay, in such in the same way, okay. So to create a free, we can say controlled motion, engineering going to engineering connection, and I'm going to select this the plane, that is the right plane and the right plane, okay, of the left or right disk, okay. So you can see they suggest you to add this met or connection in a cylindrical already created, which we created here, that is the cylindrical 5. So I will say okay. Okay, so they will create it. Now just make it replace by angle, okay? And again right click in mode trap, define as controlled. You have to you have one controlled feature to create a mechanism. Please note that you have to be create a controlled a single controlled engineering which will drive the mechanism, okay. So controlled, here you define your angle, that is 0, 180. Just double click on the tab, 180, 360. Click OK. Click OK. And now to update all this command, just update. So now you can see it's updated. Okay. Anyone have any problem in creating the controlled engineering connection? Let me know, please, because this step is very important for uh, simulate or create the kinematic simulation. This is the one of the most important step. Let me check if you have any question. So let's take time to load, sir. It's clear. Okay. So everyone created this connection, controlled engineering connection, or if anyone have any problem, let me know. I will take control of your screen and let you explain you how to do it again. No problem. But this is very important. Hello. Anyone can reply? Okay. Let's.
Yes, sir, it is fine.
Okay. So once you created the assembly, no, just go back to your compass, search for mechanical system design. Okay, it's define the what we say the mechanism. Okay, this app is for define the mechanism. Okay, so select mechanical system design. It will launch and you will see the mechanical system design app. Okay, here what you have to do, just click on mechanism representation. Okay, just wait a minute, I will take this here. So in mechanical representation, you name out your mechanism or keep its same. Okay, so in my case, I will name it as Oldham. Okay, and okay, click OK. So as I already say you, that's this arrow define that there is a freedom, okay, in which you can rotate the mechanism. Okay, so to know that is how it's going to be rotate. Okay, that is showing that rotation, right? So to explore it more, just click mechanism representation oldhams. In this use commands, and in this command one double click on that. Okay, so you will get a mechanism player. So now anyone have any doubt to reach out mechanism player? Means step you miss or facing any challenges at any point of at any point? Reply at comment. Okay, that's good. So in mechanism player, no, you simply play this. What I'm doing with the robot, no, you can do the same with this. That is just, you can see that's just you can rotate this mechanism. Okay, so I'm going to close this. Now it is not a self-driven, right? You have to move the slider to rotate the mechanism. To do its Kinematic Simulation, now you have to switch to next app, that is experience. Okay, you are already having mechanical system experience. Please note down that is this app is under engineering expert role or system designer. Okay, just for your reference, this is under engineering expert or a system designer. But if you have a search tab, you just search mech and you will get in my app. Okay, so click on the mechanical system experience and create a new kinematic scenario. Okay, and here you have to again rename whatever you want to name it. Old sorry. So now I going to at my final stage, that is creating the kinematic simulation. Okay, so for kinematic simulation you need some type of excitation which is driven by different methods. Okay, so I will in brief, in short, I will show you that the law excitation, the velocity law excitation, force law excitation, and torque law excitation. So there is so many ways. Okay, and uh, we will provide you, if you want to learn it in details, we will provide you the content also, the tutorials regarding kinematic simulation. Okay, so for now we don't have any excitation. Close, cancel this, or click cancel. Okay, so now first create a law excitation. Click on this law excitation. Okay, first click on law excitation. Okay, anyone have any doubts? Just go to the compass, select mechanical system experience, and after that just create a new scenario, and the end is law excitation. Is it understood or have any doubt? Okay, so in law excitation, what you have to do, you have to select the command, because you have to define, no, which law is means which command you are going to control by law excitation. Okay, so support, click on support, go to the your mechanism representation old times coupling, select the commands, and here you will select, you will see that these commands is depend on the right and left disk and the mounting base. Okay, so I'm going to select the command and you will see this is applied here. Okay, so just click OK. So in a scenario, in excitation tab, you will see the law excitation is created. Okay, so now law excitation created, but to drive the mechanism with respect to time, you need the you need to give the movement, right? To do that, just you have to create a table. So for that, just go to tools. Okay, in tools you will get a table, design table. Just open that. For that, just select create a design table with current parameter value. Okay, and select OK. So anyone have any problem to resolve to the design table? Just go to the first create your law excitation. Understood how to create a law excitation, or have any problem, have any doubts in creating the law excitation? Please comment in the chat box. So I will move forward. Okay. So first you created law excitation. Now you have to create a design table according to which it's going to be manipulate, or we can say work, going to be work. Okay, so just go to tools, select the design table. In design table, select create a design table with current parameter value. Okay, which you already define. They will create the design table according to current parameter value. Okay, and just click OK. Here you have to add which parameter you have inserted in your table. So in our case, we need just one angle and a time. Okay, so in this case, we have only two parameters which is going to be control the whole mechanism. That is one angle and second is time. So click OK. Just move the arrow, just move the parameter just by using these two arrow. Okay, click OK. Just say yes. Here what they're asking, you are about to create Excel sheet. Click yes you want to continue, or if no, if you want to create a text file. Okay, so if you have an Excel sheet properly working on your PC, go with Excel sheet. If you not have this Microsoft Office Excel sheet, you can use the text file also. Okay, to change. So I have an Excel sheet, so I'm going yes. So just wait a second. So now create a table. So already name as design table. I'm just adding the old hands and click OK. So this is the name of table, design table old hands. So again, it's asked for there are complicit between this table and with other relation. You can either remove complicit associate yes or deactivate complicit relation or deactivate the design table. So simply cancel it, no issue. Okay, and now to edit this table, no, just go to edit table. Just like your Excel sheet, let's make a table with starting at 0 angle. Okay, 0 angle, and the first angle is 30 degree with 0.5 second. Then we have 60 degree in 1 second. Okay, and we'll just extend it till 360. Similar for this. Okay, or you can do, as our first angle is 180, the default angle is 180, so we can do 180, then 210, and by this you can again continue. Just wait a minute. Okay, so we will continue with this that is 0, 30, 60 till 360, and make sure you save this table. Okay, so save, so it will be saved. Close the table. Okay, and close that also. You will get all the values, that is 0 degree for 0 second, 30 degree for 0.5 second, 60 degree for 1 second. Okay, apply, save. Okay, okay, so your excitation is ready. Now go to scenario. Okay, just we are at the last phase. Anyone have any problem, any doubts regarding design table, or you can say the log excitation? Have any doubts? Hello. Okay, so now we are going to create the kinematic scenario. Just switch back to scenario tab, select kinematic scenario. Okay, so here you get log excitation. Select this log excitation and move reference and preview. So in preview we will player. In this, select the continuous rotational. Okay, so it will be in loop, and just play. So you will understand it's not going to show anything. So again, do it this and play. So just wait a minute. There is a problem. Okay, so there is if any problem. I think in table we mismatch some values. Okay, so let's edit again. Just double click on the table, so it will be able to, you will able to edit again. There is no yet. Just click it again. So you can see the, okay, so edit table, save it again, close. Okay, so let's I think there is some issue regarding the table inputs. Okay, the excitation angle, there is no excitation angle. So instead of that, we will delete this table and make it again. Just go to table, design table, current values. Okay, select angle and time. Okay, design table, whatever name it have, no issue. Okay, so click here no. Okay, and edit table, do it same as 180. Sorry, first start with 0, then 30, 60, same for here, 0.5, 1, drag and drop. I think most of you know how to use Excel sheet. Save it and close. So close this. You will see the degree and the time second. Okay, and now we are going to again just delete this scenario which we already created. Go to scenario, create a kinematic scenario, just move the log excitation, preview. So check it, it's now moving but it's too fast. For that consideration, slow down the speed, create a loop, play. Okay, it's little bit understood. So now again speed it little bit more slow. Okay, and you will able to see the rotation motion. Okay, so which I already created, I will show you with this. It will be better for you to understand. Okay, so what you have to do, just okay, so I've created this. So anyone have any problem in sorry, have any doubts in creating the kinematic simulation? Okay, you will get all this file in space, 3D space, so no worry about that. If you're not able to create the kinematic simulation, you can check out. I will show you once again. Go to my content. Okay, here no, you will get the file regarding kinematic simulation also. So you can play this file, kinematic simulation, to understood how to just use the already created file. Okay, yeah, you having a, if you want to show it a minute, I'll show you again. Open. Yeah, in meantime, no, you will check out the user assistant or user guide tutorials also. The tutorials is also available regarding the mechanical system design. Okay, so this is already created part. Okay, in this to run a kinematic simulation, I will just go to the scenario, double click on it. Already have a law excitation reference, just preview. Okay, and you can see this. Actually, I'm not getting what is the problem then. Just update, edit feature scenario, broken. Okay, so there is some during the creation of model, no, I already used some model, that's why it's broken by someone. Okay, so no problem. So yeah, this is end from my side. Just a minute. Hello. So anyone have any doubts still now?
Saurabh, do you want them to speak out? Then probably we can give them
Yes.
permission to talk. Okay.
Yes, sir.
I think they already have, but Dharminder, can you give everyone permission to talk?
Yes, now all are on mute. Anyone who want to talk can talk.
Okay. Seems there is no doubt, I think.
Okay. We will up just for a student, if they have still have any doubts or miss any process steps, we will upload this complete video of Olam's coupling on our 3D swim community. Okay, so you will able to create this mechanism again in your free time. Okay.
Yeah.
So the from this session, I will just like to end my session with the key takeaways from the presentations. Sorry to interrupt. Just the key takeaways from this presentation is to app available experience engineer and 3D innovator roles, how to use that app, which key commands available in the apps or roles, the design of part by using part design and Xdesign app. Okay, and the assembly of parts by using the 3D innovator role and also by using the assembly design app. The creating the mechanism at the in native application, that is mechanical system design and mechanical system experience by using the kinematic simulation. Okay, so yeah, so thank you for everyone for quietly listening and doing the all the exercise. Thank you so much. If you have any question, please feel to ask in comment, or you can ask in. Okay, sir. Actually, do Lloyd sir is here?
Saurav,
Yes, sir.
Saurav, what you can do is still we have nearly 1 hour 15 minutes or so. Okay, so you can
Okay.
ask attendees to create models or part design, components or assembly design. They can work on themselves. They can explore the platform, and in the meantime, you can be there. So if somebody is facing any issues, then you can help them.
Okay, sir.
Okay. Uh,
So the drawing files are available on 3D Space. I hope you all able to access these drawing files, and you can start your model creation. If anyone facing any issue, I will help you with 3D modeling also, and you can share your screen with me. So it will be beneficial for all other participant also.
uh, Dheeraj sir, you there?
Yes, I'm there.
You have any comment on this, sir?
No. I think it is wonderful. Let students work it out.
Okay.
We can
I
wait.
think in the meanwhile, I think, sir, we can pause the YouTube live session if not
Okay.
required, I guess.
Fine. I think the training part